Hey guys, it's me, Miss Smith here, and today we're going to be going over the Probability Lab coin flip. So remember, if you're doing this digitally, to make a copy of your own. All right, notice how mine says copy. Okay, here we go. So a few concepts have had greater effect on the science of genetics than the laws of probability. Probability refers to the chance of something happening. Under normal conditions, probability calculations can give us good ideas of what to expect from different genetic combinations. A thorough understanding of probability was instrumental in leading Gregor Mendel to his basic conclusions about genetics, and these same laws of probability play an essential role in genetics today. So, when it's talking about the chances of something happening, for probability, we're either finding a percentage of something that's going to happen or a ratio that's going to happen. In this lab, we're going to focus on percentages of something happening. In this case, whether we flip for heads or tails, hence the coin toss. So our objective is to explain the roles of sample size in estimating probability. We're going to calculate the probability of occurrence of a single event, and we're going to compute a percent deviation from expected values for data gathered. So don't let all those big words scare you away, okay? Basically, we're going to do some math calculations for percentages, and we're going to explain why these percentages are happening. And we're also going to explain what's the difference between flipping 10 times versus flipping 100 times. That's it. All right, so here we go. So before we even start anything, we need to make a prediction for this lab. So for the procedure, what percent do you expect to flip for each side of the coin? Now, we have heads and tails. And when we are deciding for heads and tails, we need to make sure both of those numbers equal up to 100%. So what do I mean by that? So let's say, for example, I decided that my prediction is I'm going to flip heads 60% of the time. And so 100 minus 60 is going to be 40. So the remainder of the percentage for tails will be 40%. Okay. All right. Now that we've made a prediction, we're going to go ahead and do the actual coin tossing, okay? So our materials, it says 2 coins, but really if you have just 1 coin, it'll be fine. If you have a phone, you could use that. And if you don't have a phone, but you are using the computer, you can just go to Google and type flip a coin. Sorry. It's always when I'm trying to record, I get all these messages. Okay, so flip a coin. Okay, so you can type into Google to flip a coin. You can also tell your phone to flip a coin. Make sure you are connected to Wi-Fi. So here I'm going to go ahead and demonstrate. Hey Google, flip a coin.
You got heads.
Okay, so it'll tell you you have options for flipping coins, okay? So sorry. I'm going to put this on mute. I'm being a terrible role model right now, as if we were not in the classroom. Sorry. Okay. Sorry about that. All right. So for the first part, we're going to toss a single coin 10 times. So we're going to do this by recording the number of heads and tails that result. Record your results below using tick marks. Okay, so how should that look like when you're doing this? So think of it as like you taking actual score. Right, so this side is going to be heads. This side is going to be tails. I'm going to split that down right in the middle. So here we go. So I'm going to tell that Google to flip a coin. So here we go. So tails, so I'm going to do 1 tick mark for tails. Flip again. Tails again, so I'm going to go ahead So see, I didn't write the number 2. I'm doing a tick mark or a tally mark. All right, heads. So I'm going to take a point. Tails again. So far I've flipped only 4 times. 1, 2, 3, 4. So I need to flip 6 more times. Heads, so tally mark. Heads again. I'm going to flip it. Tails. Right? Tails again. So when we get to 5, we're not going to do another tick here. When you have 5 for tick marks or tally marks, you're going to do a slash right down the center. So 1, 2, 3, 4, and then 5 is going to be the slash. So this whole thing represents 5. So far we have 5 for tails and 3 for heads. So that's 8 flips. So we need to flip 2 more times. So tails again, and they're going to flip one last time. Tails again. All right, so in total, now we can go ahead and put our answer. So 1, 2, 3, and this whole thing represents 5. So 5, 6, 7, and that's going to give us 10. So I'm going to go ahead and double click. I'm going to type in here 3 and type in here 7 and make sure it's in a different color. All right, so that's how you're going to keep track or record your results. So if you have a piece of paper and a pen, it should be just easy to do the tick marks, right? If you want to count in your heads, that's fine too. I suggest doing the tally marks because further down the road, you're going to have to do this 100 times. That's going to be a lot of remembering how many times you flipped for what. All right, so let's say we've collected our data, which we have. Now we're going to go ahead and calculate, okay? So we are going to calculate the percentage for heads, okay? So what is this math going to look like, okay? So first off, we know we flipped 3 times, and 3 is going to represent the number of heads flipped. Oh, excuse me, the number of times we flipped for heads. Okay, and then 10 is the total amount of times we flipped, regardless if it was heads or tails. So 10 is the number of total flips in all in this first part. Okay, so what do I do with those 3 numbers? Well, I'm going to show you the math, right? So here it is. I'm going to do 3 divided by 10. Miss Smith, do I need to show my work? Absolutely you do. Okay, so in the calculator, I'm going to do 3 divided by 10. Okay, and that's going to give me 0.3. However, we need to calculate percentage. So this is a decimal. So in order to calculate percentage with the decimal, right, I need to times this by 100. Okay? So 0.3 times 100 is going to give me 30%. Highlight this in yellow so you can clearly see that that is my answer. All right, we're going to do the same thing, but for tails this time. So how many times did we flip for, that changed the color. How many times did we flip for tails? Well, we flipped 7 times. So I'm going to do 7, okay, is the number of times we flipped tails. And again, we still have to use the number 10 because we use 10 total flips in all. And 10 will represent number of total flips in all. Okay? So I'm going to do 7 divided by 10. And again, if you're math savvy, you already know that it should be 0.7, but I'll show you the math anyway. So 7 divided by 10 is going to be 0.7, and I have to multiply that by 100, which will give me 70%. Right. Another way you could have figured out tails, you could have literally just did 100% minus 30%, and that would have also given you 70%. Okay, so how you do that math in your head is, you know, basically you should be getting these numbers, and I need to see your work. Okay, can you use a calculator? Of course, yes, you can. It's part of the materials. Okay. Now, we've answered 3 and 4. So based only on your observed, so our observed, which would be our experimental, what do you expect to flip next? A heads or a tails, and explain your answer. So I'm looking here at my data right here for number 2. So if I were to tell Google to flip a coin again, what do you expect is going to be flipped? Do we expect that it's going to be heads that's going to be flipped, or do we expect that it's going to be tails that is going to be flipped? Okay, so based off of my results, I would say tails because it has the highest percentage. So that would be my explanation. Again, if you got something else, let's say when you did it, you flipped more for heads, then you would argue that, well, I flipped heads, had the higher percentage, so it's going to be heads is going to be next, okay? Again, it depends on what you get when you flip for your data, okay? Number 6, compare what you expect from number 1 with observed results from number 3. Did you observe what you expected? So basically, did our data support our hypothesis, our expectations? So we had said that 60% would be heads and 40% would be tails. Well, obviously, that is not what I got for my data. I got 30% for heads and 70% for tails. So here, number 6, I need to write that down. I need to explain that my prediction is different from my actual data. So my data doesn't support my hypothesis, at least for this part of the lab. Okay? Now, you're going to do the flipping of the coin again, but this time you're going to do it 100 times. So that's why I stress that you do the tally marks on like a separate sheet of paper, just so you don't lose track of how many times you flipped, okay? And 8 and 9, again, you're just calculating how many times you flipped for heads and how many times you flipped for tails. So you're basically following the same formula as up here, except this time you're not going to divide by 10. Why are you not going to divide by 10? Because here you flip the coin 10 times. So instead of dividing by 10 here, you're going to divide by 100. Why? Because this time around, it's telling you to flip 100 times, okay? Number 10, you're just comparing your data again to your prediction. So is it going to be different versus if you flipped it 100 times? Now, number 11, it says compare your answers from number 6 and number 10. So whatever answer you got for 6 and whatever answer you got for 10, you're just comparing the results. Did you get better, meaning more accurate data when you flipped more times? Did it not make a difference? Explain your answer. So for here, you're deciding, right? Is it better to flip 100 times versus 10 times? Are you going to get more accuracy if you flipped 100 times versus 10 times? You're going to explain your answer, and you're going to explain what those differences are, what those accuracies are for 10 flips versus 100 flips. And that's it. That's all you're doing for number 11. Okay? Please make sure that we don't have all this extra space. So if you have extra space, just remember to delete. Okay. I hope this video has been helpful, and I will see you guys in the next video. I hope you guys have a wonderful evening or morning, depending on when you are watching this. All right. Bye, guys.